hope you're keeping well. Today I'm going to jump into some worked examples for some annuities, some mixed examples here. So let's get into it. An annuity of 1,800 per year will have 18 payments starting in X years. Interest is 6% per annum, and the present value of the annuity is 10,881. I'm doing this question under the assumption that these payments are in advance. When the question doesn't specify whether it's in advance or in arrears, then whatever you're you're going to interpret it on, you must just write down your assumption, because that your answer might be it will be slightly different. So let's start by a nice timeline. Always a good place to start. And I noticed that the payments are starting in X years, so this is deferred. So X years. So how I'm going to tackle this is I'll present value the stream of payments to this point, and then then we can work out, because the present value, this 10,800, that's here. Okay, so let's do it. An annuity 1,800 per year will have 18 payments starting in X years. So I'll start with the first payment being here, right? And they said that there's going to be 18 payments, so up until that's 1, there's going to be 18 payments, and the interest 6%, and that's per annum, and our annuity payments are per year, so everything's good. I'm happy. We can get into it. So let's work out the present value at time X over here. This there, that's my time X. At time X is equals to A, right? Because this is in advance, our first payment is occurring in X years, and then our interest rate is 6%. So we've got our present, we don't have that present value, we're going to calculate it. We can do this formula. What's happening? Oh, 1,800, I must write here. This whole thing multiplied by 1,800, because that's the annuity payment they gave us. And now we're going to go pop this in a calculator. Gives us so this value here is our present value at that time, but now we need this present value, so we can do this. We know that the present value is equals to equals, so we need to discount this, the value underlined in red, this the value. You discount it, and we know the interest rate is 1.06, and we're going to discount it X times, because we don't know how many years, so negative X. So let's do some math. I'm going to divide by 20,000 on the left side. It's going to be I'll introduce a natural logarithm. Negative X there. So let's do this straight away. Right, which gets us to times. So when we calculate for X, it's going to be 11.000 something. So we'll take it as 11. So X is 11 years. The question said calculate X. So we're deferring this annuity for 11 years. Hop into the next question. An increasing perpetuity. Oh, perpetuity, what is that? What perpetuity is, that's just an expensive word for, it's an expensive word for meaning forever. Let me write some stuff here. as n tends to infinity. You can do like the limit. So if we take our annuity formulas, I'm going to take this one. Remember that one, that's the annuity formula, 1 minus b to n over I. Right, that was the annuity formula for payments in arrears. If we take the limit as n tends to infinity, we're going to have, let's remember this is equals to 1 minus 1 over 1 plus I to n, right? So now as n tends to infinity, this right here, this is going to go to 0. So we have 1 over I. So perpetuity might sound like a lot, but it makes our calculations a lot easier. So back to our calculation. Now that we know what perpetuity is, take this down, I'm going to remove it. Okay, the question, what's it saying? We have an increase in perpetuity, nice, paying out quarterly payments starting one quarter from now. The next payment is 300. Payments grow at constant rate X each quarter. The present value is 25,000. Interest rate is 4,000 per year. That should be per quarter. But if the question gave it per year, we would change it to per quarter. I'm just going to leave it per quarter. So how are we going to start this? So we've got the present. This isn't deferred like the first question. We have the present value of 25,000. And we have the payments are 300, but they're increasing. So that, remember, with the increasing annuities, we're going to treat it as a level annuity with interest rate J, which is the interest rate that accounts for growth. So you do n is going to go to infinity with J. And we just spoke now with the light blue, and I was explaining what perpetuity is, that this is going to be equal to 300 with 1 over J. So now if we work out J is going to be equals to. Now from increasing annuities, we can remember this formula. Right, and in this question, because they gave us the interest, and now we want to work out the growth. So let's do that. So we have J is equals to 0, equals to 1 plus I over 1 plus G minus 1. 1.04, 1 plus G minus 1. Now we just do some math. Right, and that's our answer. We're supposed to calculate x, so we'll just tell them x is equal. Right, that's our answer. We wanted the growth. Grow at a constant rate that each quarter, and this is the quarterly growth because we use the interest rate, which is also per quarter. All right, thanks. I hope that helped. Keep well.